Okay, Julie Dahl is going to talk about some of the farmer implications.
Good afternoon. So my colleagues have presented some of our research that can inform mitigation practices. And here what I want to do is take a step back and broaden the discussion a little bit to consider some other factors that we need to discuss and focus on for those research results to be effectively implemented on the ground. Now, I'd like to acknowledge my co-authors as well. So I'm going to give you a visual roadmap for today's talk. Basically, science is producing information on mitigation practices. By mitigation practices, all I mean is that ways that we can farm the land to reduce the severity of climate change. And so here's a picture of some of our research at the Kellogg Biological Station. That contraption in the middle there is the equipment that we use to measure greenhouse gases being emitted from different ways of farming the land. But we also know we can have all the good science in the world, but it's not going to have any impact unless that science is implemented on the ground by the farmers, right? And so to do that, we really need to bridge this gap. And so my talk today is basically going to be this yellow arrow right here. So we've heard a lot today about how farmers are and will continue to be affected by climate change and the change in environment, right? Changes in CO2 levels, precipitation regimes, temperature, drought severity and frequency, any one of those individually, let alone the interaction between the two. They're all going to have effects on plant growth, outbreaks, irrigation needs, soil and water quality. And as we've heard today, some of those effects might actually be positive and help farming. But I think that when we take into consideration all these things and more, the general consensus is that it's going to be more of a negative effect. Climate change is going to have more of a negative effect on agriculture, as the literature is showing. So at Kellogg Biological Station, we're researching different mitigation practices, and I'll just give you an example of two of them. One of them is no-tillage farming, as the previous speaker mentioned. That's where we don't disturb the soil, and we're finding that that can sequester more carbon than conventional tillage systems. Another mitigation practice is reduced nitrogen rates, which can lower the emissions of nitrous oxide, which Phil mentioned at the beginning and which we'll hear a lot more about in the next presentation. So we know about these mitigation practices. We know that you can farm this way. We know that you can still produce the same amount of crop farming these ways. But we also know from researchers at Michigan State University that these and other such conservation practices aren't always widely adopted. And so this is work by Professor Scott Swinton and his team. They conducted a survey of 1,800 corn and soy farmers in in Michigan in 2009. And what they found was that for the practice of using no tillage for 4 or more years, there is a third of farmers who are doing that. Over half have never tried. And some have tried and don't use it anymore. Using the PSNT to guide nitrogen application rate is another example. PSNT is a soil test. It was designed to provide agronomically and environmentally sound nitrogen recommendation for farmers, so they know how much nitrogen fertilizer to apply. Once again, we see there is a percentage of farmers using this, but over 65% have never tried it as well. So why? Well, the literature is rich in these barriers to adoption of any sort of conservation practice or project on the ground. And so we know that all these factors, attitudes and perceptions, financial capacity, which is huge, management skills, the flexibility of incentives, literature is rich in showing that these all influence if conservation practices are implemented on the ground. And this literature is speaking about conservation practices more in general, not just about climate change. So even knowing all this, the literature also shows that actually identifying reasons for predicting farmer adoption can be difficult. So it's tricky. And I would argue that it's even trickier when we come to issues such as climate change and adopting mitigation practices, because climate change has its own unique challenges as opposed to other conservation practices. So here what we're looking at is just a screenshot of the Michigan Farm Bureau website. And from the 2010 policy book, we know their stated policy on climate change, and I know you can't read that, so I'll just read the first line. Currently, there's conflicting scientific evidence about global climate change. The Farm Bureau does not endorse any views on climate change. So this is from our state Farm Bureau, right? And so when it comes to climate change, one additional challenge is the perception that maybe it doesn't exist at all. That said, I will say I've been at meetings where there are farmers who are very concerned about the changing climate and who are actively working with scientists on it as well. And I think that they provide us a really great opportunity, and they're an invaluable resource to us. But another challenge, also from Scott Switton's work from his farm survey, is that farmers don't see global warming or climate change as relevant to them. It's more of a societal issue, not a farming issue. So in their survey, they asked farmers to rate how important these various things were to them personally or to society. And so we see that practices such as increasing soil organic matter, increasing soil conservation, those are very important to farmers. They really take that as something that can affect them. But when it comes to reducing global warming, maybe that's not a problem so much for me. That might be a problem just for society. And from focus groups by Professor Swinton and Professor Luthi, they found that farmers expressed doubt that anything that they did on their land would actually have an impact on global climate change. So I mentioned the opportunity to work with some of the farmers already engaged in climate change issues, and another opportunity I think we have is the connection that farmers have to the land. So farmers are noticing things are changing, and they're telling people that they're noticing things are changing. But what's interesting to me is that at a meeting, I was speaking with a colleague who farms himself and works with a lot of farmers, and I asked him, are the farmers that you're working with, do they believe in global climate change? He said, no, not. And I said, well, are they noticing things are changing on the ground? Yeah, absolutely. They're noticing things, rain patterns are changing, more extreme rain events, et cetera, et cetera. So they're noticing these changes, but they may not call it climate change, which, as we know, can be a very loaded term. This connection farmers have to the land can also provides an opportunity because they're very well aware of the variability of climate. They live with it every year when they have to plant things at a different time or harvest at a different time. And there are scientists and extension specialists around the country who are using farmers' understanding of climate variability to help them understand climate change and work with them on climate change issues. And that's an opportunity as well. So how do we take this knowledge that science is providing us on mitigation practices, the sound science, how do we take that with the challenges and the values of these different stakeholders, farmers and others, and actually move forward to help with mitigation practices getting implemented on the ground? It's messy and it's complex. And so I'm going to ask for your participation for 1 minute. I'm going to put a word up here on the screen, and I'm going to ask, what do you think of? Just shout out a word or a couple words when I say the word debate.
Fight.
Fight. Anything else? Pardon? Controversy.
Angry.
Angry. Contention, right? Other people have said winners, losers. All right. What about dialogue? Consensus.
Exchange of ideas.
Exchange of ideas. One more.
Listening.
Listening. Absolutely. So what we've talked about are just two ways that we could interact, right, to deal with this issue. But if you notice, both these ways are about talk, dialogue. There's nothing that was taking it to the next level. Well, there's a third way that folks are using, and that we're putting our energy and efforts as well, and that's called deliberation. So as opposed to debate and dialogue, which basically are a bunch of talk, not that they're not valuable and useful, deliberation actually finds the common threads of a group, of evaluating the issue, a difficult issue, and moves it towards action. So it involves multiple stakeholders with varying values who develop a shared understanding of the issues at stake and decide how they're going to handle it. So there was a panel on the strategies and methods for climate-related decision support, and this was from the National Research Council of the National Academies, 2009. And they found that this deliberation was the method best suited to make decisions about the changing climate, just because it is such a complex, loaded issue, right? And we heard this morning, they talked about that. They talked about bringing the various stakeholders. They talked about the need for consensus, and that's how they were, by having all those stakeholders, they were able to get 97% consensus in Michigan for some of those issues. So we're fortunate that Michigan State University Extension is a leader in this deliberation, and we're excited at our lab to partner with them and start working with Michigan State University Extension educators and some farmers and helping them deliberate ways that we can implement mitigation practices on the ground. Another approach we're using is the use of a new tool that was created by data both that we've generated and other data as well, and that's called the U.S. Cropland Greenhouse Gas Calculator. And so this is a research-based tool that farmers, policymakers, anyone can use to help them understand the greenhouse gas impact of different ways of farming the land, of different cropping management. So there's a link to it on our website, and I'll just walk you through one example. So the first page shows a map, and each county on the map is clickable. So you can click which county that you're in and what your county of interest is. It takes you to a page where there's a base scenario, and I chose Tuscola County here in Michigan. And so it has, based on USDA data, it has average corn and soy yields, it has the average environmental conditions as well. And so a farmer or a policymaker, whoever, can go in and adjust these as they'd like, or they can just use this base scenario to find out if I have corn-soy rotation using conventional tillage and using a given fertilizer rate, what is my greenhouse gas cost of that type of management? And this calculator will tell you. It's 0.44, and the units are carbon dioxide equivalents. So that's all good, and it's really neat that you can tailor it, to what the conditions are on your land. But what is especially great about this tool is that it allows farmers and others to compare. Well, sure, so I have this given land and I have a corn-soy rotation with conventional tillage, but what if I were to switch to a different practice on that same land? How would that affect my greenhouse gas cost? So the tool allows you to add a scenario. We're going to add another scenario that we want to compare to that baseline scenario. And so I just made one simple adjustment here. All the same information, corn, soy, same Tuscola County. All I did was change the tillage. So now instead of conventional till, we're using no-till. And then it calculates, once again, the greenhouse gas equivalents for both the baseline scenario, the first one I showed you, and then the new one, which is lower. And this difference between the new scenario and the original scenario is depicted up here, both graphically, which is hard to see for you, but also numerically. And so we see that just that one simple switch from conventional to no-till, we have 0.31 carbon equivalents less greenhouse gas impact. And so we think that this tool could help bridge that gap between farmers not thinking that what they do on their land can really make a difference. We also think this tool could be useful with the markets that Phil mentioned in the beginning, both the carbon market and the potential new markets, which our next presenter will talk about as well. So just in summary, I'll put back up the roadmap. Lots of great science, lots of great farmers, but this yellow area is something that really needs to be addressed. And that yellow area is messy, right? It's complex. It's not very easy to be in. It's kind of scary and whatnot. But we're actually excited about the opportunities. We're excited about working with farmers and others around the state, hopefully some of you all. And we look forward to your comments and questions. Thank you.
Julie, couple questions?
I have a question,
Yeah.
or actually two questions. One, I see you had the policy up from Michigan Farm Bureau, and I sat on the delegate floor while that discussion was taking place. And some of the comments that I seem to keep hearing from farmers are, and Jeff, don't take this wrong, is we rely on our forecasters to forecast our weather so we can plan our operations for the next 2 or 3 days, and they can't get that right. How are they going to predict climate change over 100 years? And then the second thing is, like the calculator where you change the tillage operation, who's going to pay for that? And who should be responsible for that? Because there's costs by going from conventional till to no-till, or some other operation change, reducing nitrogen application rates. Who's going to pay for that?
So maybe I'll start on the second question and then pass to Jeff for the first one. I think that's a really really good question, Dennis, and I think that's why we need these various stakeholders at the table. But I would also argue that some of our research is showing that some of these mitigation practices probably won't cost farmers money, such as altering the nitrogen fertilization rates, which could actually save them money in the long run if they've been over-applying. When it comes to no-till, are you talking about added cost of new equipment, et cetera, or?
Well, there's a adoption period with switching to no-till, and until you get your system figured out, there would be lost revenue in terms of, you got your system figured out and tweaked it to the maximum potential you can with your current system, and you switch to no-till, yeah, you gotta have a different planter, different equipment, but it's a different mindset. You learn some things the hard way.
Right, so maybe there's a lot we can learn from the farmers who have switched without perhaps other incentives. And maybe that's part of the talk of designing incentives for farmers as well. It's a good question. And I want to let you take that other one.
Maybe that's a rhetorical question, so.
That was
Well,
just a stamp.
we have thick highs, I guess. Heard it all before. Just a couple quick comments though, in terms of there have been some interesting trends in the last couple of years. And I'm sure Scott can follow up on this as well. I've been talking about climate change in the agricultural community almost 20 years, and one thing that's really noticeable is in the last few years, there's been a definite change in attitude. And I think a lot of it goes back to uncertainty about information or misinformation that's made public, and confusion, and the realization that we're talking about some really serious decisions. And some of them may impact individuals economically, fuel, taxes. There's a number of issues here at stake. And if the science is not dead on, black or white, and of course there's not, it's still evolving. There's some reluctance. I guess I can appreciate that. But that being said, what I see as being particularly exciting is that many growers that you meet with, if you ask them, would you change your practices or alter what you do because of climate, they'd probably say, no, I'm not interested in that. But if you look at what they're really doing, they already are adapting to changes in climate. They may not even know it. Longer season varieties, Michigan's warmer and wetter than it was 40 years ago, and agronomically that has some advantages. There are a number of things that have happened, and this is true across the Midwest, that are actually adaptive strategies, and they don't even realize it. So there's a lot of this interaction that needs to take place a lot more. But it's a very complex situation, and we have to remember that people do this for a living, and that's first and foremost.
We have time for one more question.
I don't think that at the end of Jeff, if you go back to your graph of the horizontal bar graph showing the negatives, you get the climate mitigation, and then you had a bunch of other practices. All those other practices you listed are adaptation activities that, if done right in the proper place or the proper time, I mean, those are adaptation activities. So I guess I'm kind of challenging you a little bit that frame this into the mitigation thing. And you might say, reducing global warming is a mitigation thing. Well, I would say that's not me either. But all those other all these other things are really adaptation activities, depending upon where and to the extent and the timing of them. And so there are many things that are being implemented that are climate driven or can be, or the opportunities to make them more climate smart than they already are. Those are all good things that have been done for many, many years. Continue to do those types of things. They're going to make a whole lot of sense in terms of adaptation.
Yeah, and just to expand on that a little, if I'm following your train of thought, I appreciated the question this morning. Someone asked, well, is adaptation and mitigation mutually exclusive of each other? They were asking, and obviously not, right? So I think you bring up a good point.
Thanks, Jim.